Hey folks, welcome back to the channel. Pretty excited to announce the next project that I have. 1961, this was probably purchased by a factory or a shop for maybe a foreman to ride around in with his clipboards and stuff and inspect production or whatever. But also it might have been used to tow some vehicles around. Bought this when I was getting some parts for the Volkswagen Thing project, which was a previous video that was completed, and I found this in a barn. So this, yes, it is a barn find, but thought it'd be a neat project, so gave the guy a couple $100 for it, loaded in the back of the pickup truck, and brought it home with some seats that I bought for my Volkswagen Thing. Alright, so here in Kansas, and I bought a little electric scooter here. This is going to be like a musty one video. It's electric scooter. A Westinghouse scooter. Electric. So the question is, will it fit with my cap? We're going to get a wrench and spin those handlebars upside down. And I think it's just going to make it in there. The answer is it fit right in the back of the pickup truck. It's going to be a cute little project. This will be an upcoming YouTube. So check this out. You hot rodders know what I'm talking about. Look at my other builds. But this scooter has a 9-inch Ford rear end in it. Unreal. With an adapter to the third member, and that's tied onto the electric motor. But on the one side, the axle must only be like 4 inches long, and on the other side, that's probably maybe 12 inches. But this is incredible. So even if it was just bought for this, just to have a 9-inch Ford rear end in here, I think that's pretty cool. It runs on 3 12-volt batteries in series, so 36 volts. I have all the parts that I've been collecting, tires, tubes, and the charging unit, and it should be pretty complete with all the stuff that I have. And I'm assuming this is probably reverse and forward, and then middle's neutral. But I've got some modern technology to put on it, like a 4-state charger and a modern day wall outlet plug to keep it charged up. The seat comes off. Guts underneath here. There's what it looks like underneath. So some corrosion from the batteries down in there. This is your switch. Everything's mechanical. To the copper bars that are in here, and then there's your wires going to the electric motor, and then somebody cast an adapter down into the 9-inch Ford rear end, and then it uses a saddle brake going to something like a clutch cable that goes to the front, which is broken, so I need to get a new clutch cable or thereabouts made somewhere to make the brake work. And pretty cool, it has a horn in it. But the 3 batteries will just go right down into that tray, and yeah, should be a pretty cool project. So I think the next thing is I'm going to get out the pressure washer that I've got in the shop here, bring it out here. It's supposed to be 2 degrees tomorrow, so it's about 38 degrees right now in the sun here in Colorado. But I want to get this all cleaned up, and then I'll bring it in, and I think the first thing I'm going to tackle is the brake cable. Get that finished up. So I'm going to pressure wash the cart, but if you guys have never heard of a foam cannon, this thing's amazing. I use this all the time on the front of the house up there before I painted this past summer. Use it on the cars, but this is made by Chemical Guys. I'll put the Amazon link in the description if you buy one, help support the channel. But this is the Honeydew Snow Foam Auto Wash General Purpose Soap. But this jug lasts forever, and this entire jug you just fill it up with water to about there, and then you put like 2 tablespoons of this concentrated soap in there, and then don't shake it, just slightly spin it a little bit, mix it, and you're ready to go, and it goes right on the quick connect on the end of the pressure washer. But highly recommended. I've been using it for about probably 9 or 10 months now, and works really well. First project to do is to fix the brake cable, because this has no brakes right now, but this has the adapter going into the rear end with the electric motor on the side, and then at the other shaft is a disc drum, and it's got like a brake lining saddle that you just pull down and it grips onto the wheel, and that's your brakes. So this is a spring cable that runs to the front. So I need to get this nut off, and then I'll show you next where the brake's at. This is the other end of the brake cable, and you see it broke off here, and it's got probably like a ball that was on the end, like on a clutch cable that went into the slot here. And I need to somehow either replace the cable or get an end that would go on here. It looks like a 3/16 inch cable, so maybe I can get an end put on here. The brake cable's removed, and it's all corroded with the loom. It's like a coiled loom that goes on the outside of the e-brake cable. But I've determined this is something out of a late 50s car for the emergency brake, or early 60s, 60, 61 car. But I went through hundreds of pictures and I can't match it up, so I'm going to try to break this one loose. And the corrosion between the loom on the outside and the stainless steel cable inside, the corrosion probably led to its failure and the end pulling off. And I have a new swaged end coming. Should be here tomorrow. I'll put that on the end, but I'm going to break this loose. But what I've been doing is soaking it for a day in FreeAll. And if you don't have this stuff, you need to pick up a can. I'll put the Amazon link in the description. Any rusted material, it penetrates and it just eats the rust. But I put tie wraps on here. I coiled it up, and as you can see, it opens up the side of the coil because there's no rubber in this. This was old school, late 50s, early 60s. So if you have this, wrap it up tight in a coil, and you see all the little slits. We'll let the penetrating fluid get down into the cable. So I was able to break free the old brake cable. By soaking it in FreeAll, but it's still the old-fashioned cable with just stainless steel wire cable. So I was able to find on Amazon, after a ton of searching, and on eBay, a modern type brake cable that has the plastic sheathing. It has a Teflon interior, and then coiled steel, so it's very well protected against corrosion. It also has the end fittings on here, but I'm gonna have to modify the spring and stuff to see if I can get it to work. And then on the other end, I've got the same fitting which I need, and then the little ball on the end that's going to go in. So I can cut that to make it the proper length, I think. And then I have this that I ordered on eBay, and it has like little wedges that go around the cable. So and then this tightens up. But I'm going to see if I can make this work today, get this project over with. This is the modified cable. I got the new connector on the end of the wire that I cut the length, and then I was able to cut the spring off of here and modify the other end. But already had it on and took the measurements on what lengths I need, and I think this is going to work. Wow, that worked out great. The Cart now has brakes. Cable I used is off of Willie's Jeep, believe it or not, and then I heavily modified it. Next thing to do is pull these wheels off. I have new tires, I have new tubes, get the rims painted, cleaned up on the front and the back. Got 3 of them to do. And then I'm going to pull the axle out and see why the wheel seals are leaking. Probably the wheel seals are original from 1961, will need to be replaced. So I think I'm going to go into time warp. Just an update on what I got going on here. So this is the hub, and I was able to pull it off. I used a 7-ton puller to pull it off, and you see it's keyed. There is a keyway in here with a key, and the notch lines up with that. But it was seized a little bit, but the 7-ton puller pulled it right off. If you don't have one, if you're doing a project like this, you can go to AutoZone or Napa, and they'll loan you a puller that you need to return within so many days. But so the challenge is that the seal's gone. This is the old seal, and it's all just didn't do anything. The thing's been in since 1961, so what, 60 years. That's the hub, and then this is the seal keeper ring thingamajig, and it goes on like this. And then the seal goes in behind here and seals against the hub surface right here. So this is going to go in like this against that seal. The challenge is, I don't know what this rear end came out of, but if you go to, what I did is go to Napa, and they can take a measurement on the inside of a pair of calipers, and then the inside dimension there, then the outside dimension, the seal surface, and match up. They have an application on your computer, pop in the numbers, and it'll come up with the different selections that are available. But we did that yesterday, and I got this seal here ready to go in. I just need to press it in there, and fits really good, perfect. And cross-referenced like a 80s Land Rover, or a Toyota Land Rover from the 80s. But that's gonna go in there. And then this is going to go back on after I butter up the surface with silicone. And then I need to put the, this is the bearing retainer ring here, thick steel. And I'll clean up this surface and seal it. And then this is the bearing inside here. And then the axle. So that'll go on like that. This goes on like that. And then I'm done. Put the hub back on. And then I do have the castle nut that'll go back on. Castle nut has the little grooves in here. And then there's also a hole right here on the axle. So once that's in and tightened, then you put a cotter pin in there, and that keeps the nut from loosening up. So that's an important safety step. Also, a little note that on the older cars in the 30s and 40s, on the driver's side, they used a lot of left-handed threads. So when you go to take a wheel off of an old car from the 30s, 40s, maybe even 50s, old bus or a truck, the driver's side usually has a left-handed thread on the lug nut. In this case, this is a lug stud or lug bolt. And in the inside here, it has the letter L. And on the other side, it's an R for right-handed thread. So this is a left-handed thread. So many people have stripped out the threads, trying to think it's a right-handed thread, trying to loosen it, and they're actually tightening it, stripping out the threads or stretching the bolts. Next, I'm going to get this all back together again, get it all buttered up, cleaned up, seal put in, and then I'm going to wrap that up. And then after that is going to be taking the tires, the old tires. I do have new tires and tubes to go on to the rims, and then I need to clean up the rims and paint them. And then this will be back on the ground again. Back in the shop this morning, some progress on the cart here. The rear end's all back together, got it all painted up underneath. Refurbished the wheels, painted them, steel valve stems, new rubber on the front and the back. This is the color it's going to be. So I had a can of some orange, actually it's red, some red paint, and got the front done. The steps here, this is going to be bed lining, which they didn't have in 1961. And then the rest of it's going to be red. But I'm going to drill holes here for the power switch and some other items. So didn't want to paint this quite yet. And then here's the Westinghouse emblem placard across here. I'm going to pull that off and clean that up so it's readable. And make sure I mask off the serial number plate. But looking really good. After that, I need to get in and every one of the connections I need to take apart, sand, file, whatever, clean them up, put some electric grease on it, and make sure everything's working, functioning electrically. But also got some gadgets to go on. So here is the new plug that's going to go on. And it's got a flip up little flap on it that's going to go in here. And then back in 1961, they basically had a big transformer on wheels, honking thing, probably weighed a couple 100 pounds, and they would plug it into this big Anderson connector. And then it would just put DC voltage, just the power supply voltage, onto the batteries. And you had to be real careful you didn't boil over the batteries. So nowadays, though, we have a 4-state charger. This is one I picked up on Amazon. That's going to go inside, so I could just take a 115 volt extension cord, plug it in the side, charge it up. And this is 36 volts. So I have 3 batteries in series, 12, 24, 36, to operate the system. So 36 volt, 4-state chargers. This does trickle, does float, bulk, all that good stuff. And that's going to go in. And then I have LED lights. The big tail light here, stop light, is going to go in the hole that was put there back then. And then I have little marker lights in my stash that I dug out, and amber in the front, and then I'll put 2 red ones in the back. And then also, something I didn't have back then, basically an LED battery monitor. So it's going to be able to tell my state of charge of my batteries when I'm driving it. So this is going to be a lead acid marine type deep cycle battery in here. And those of you know lead acid or even AGM batteries, the voltage just drops as you use it, use the battery. So these are, I guess, geared towards each level of voltage and steps down accordingly. If you go to lithium, look at my playlist, go to some of my solar videos where I use lithium batteries. The voltage stays flat all the way and then drops off at the very end of the battery life. Also got a little headlight here, LED headlight, which is really cool. I'll put that on the front. And I've got up on the shelf a little siren. Thought it'd be neat since it looks good like an emergency vehicle. I'll have a button on there. Maybe the kids will get a kick out of that. What else we got? Oh, and then to run the lights, these are all 12 volt, sirens 12 volts. The battery monitor is 36 volts, so that'll work. But this is a DC to DC converter. So what I'm going to do is hook one side onto the 36 volt battery, and then the other side is going to drop everything down to 12 volt DC, and I can run all my lights. And then I have a couple of these also, if I need them, for maybe put one of these on the siren, depending on the load. So let's check out the progress on the cart. I've got the batteries in, 3 12 volt deep cycle marine batteries that are normally used for like trolling motors on boats and that sort of thing. And I took apart all the connections, re-cleaned everything up, sanded, put grease on all the connections, and got it all cleaned up, all the wiring. Electric motor, this is a Westinghouse electric motor. It says like 4.5 horsepower at 36 volts. This is your speed wiper that connects to the accelerator pedal right here. And this is the switch. It's kind of like a teeter-totter. It goes up and down. And that controls the voltage on the motor, the polarity going over to the motor control right there. And it's kind of like a little teeter-totter, goes back and forth and reverses the polarity on these copper bars that are in here. And the leads go into the wiper here. So I call it the wiper. This is basically insulation down here on the bottom. Then you have 1, 2, 3, 4 copper wires with these coils. These are resistance coils. You see one's a little bit bigger, I don't know if you can see that, than the other one. This is a smaller coil. So basically it's gonna take your voltage and cut it down to the motor to control the speed. So the wiper goes up and down. Let's see if I can get a shot of this. I push the accelerator pedal, and you can see how that goes up and down and wipes across each of the bars. Again, cleaned everything. Everything's greased up and works really well here, hopefully, when we go to run it. So the idea is that the voltage is coming off the battery. You hit this first bar, it's going through this coil here, which is shorter, cutting the voltage down to the motor to control your speed. Then this goes up to the next bar, which has a different resistance value off this coil. And then when you get to the top up here, that's full 36 volts onto the motor, and that's pedal to the metal. And what's really cool is back then they have this little spring here that holds tension on everything and makes electrical contact. I also got all the wires cleaned up and new cables made for the batteries. And then I have, for the first time, actually a cutoff switch for the batteries. This will totally take the batteries offline. Just flip that up and down. It's right between your legs when you're driving. So that's a good safety feature, so I'll go ahead and turn that off. But the circuit goes, all these are in series, get up to 36 volts. Then this lead over here goes into the switch, and then returns back. And I added an ANL fuse. You can see that right there. This cart didn't have a fuse on it ever, so I put a 60 amp ANL fuse, which should be fine. In case any of this shorts out and does anything weird, it's going to blow that fuse and take the batteries offline. So I've added some safety into it that the cart never had with the ANL fuse. Also the power cutoff switch, which it never had. And then I have my 4-state charger right here. This is a 5 amp 36 volt charger. And I'm going to mount it in here somehow. I got to make a couple brackets, maybe weld onto the wall here to hold this. And then the last thing I need to do is put in my 110 volt plug socket right. It's going to go right in here, and that'll take care of it. But I'd say let's go ahead and test this thing. Let's see if it's going to fire up. All right, let's give this a shot. So put it in forward. Hit the pedal, powers onto the battery. First time in maybe 4 years. Ha ha! All right. Check that out. So that's just low speed. Wow. Oh man, this is going to be fun. All right, so that's forward. Now, $100 question: where the reverse works. So now I'm going to reverse. All right. Well, that's a relief. One more time. Can't resist. It's alive! So the last thing is I need to get my voltage display. I need to make a bracket, little box that'll go right in here. I think right above the switch, stick out about that far. And that'll give me my voltage, show me my the life of the battery, how much voltage is left in the battery, this sort of thing. And then I need 2 switches, one for the lights on it, and then a second switch for the horn. And then I'm going to put that little toy siren on here. I think that'd be cute since I had it laying around in a junk box. Oh, I also have a mini bike fender that I found on eBay, a chrome-plated mini bike. If you guys remember mini bikes in the 70s and 80s, and I see them for sale like at the farm and ranch store these days too, but they were like a little cartwheel, 2-wheel, like a little motorcycle that had like a Briggs & Stratton, maybe a 5 horsepower motor on it. But anyway, the fenders were small and wide, and I found one, a chrome-plated one, brand new in a box on eBay for like 11 bucks. So that's coming. So it'll get a fender, get the lights siren on, and get the lights finished up on this, and that'll be it. Against the wall there, you see the reconditioned rims for the 74 Super Beetle project restoration that I have. Check out my playlist. I think I'm up to part 5 on that. Totally restored. And it's going to be a Tesla conversion. So it's going to be Tesla powered here in the near future. So after this cart gets done, the Super Beetle's coming in here for the conversion. But and then we'll do a YouTube on that. But anyway, let's go ahead and wrap it up. Check out my playlist on all my solar projects, diesels, Power Stroke, the Cummins, all the stuff I've built. And please like, share, and subscribe. Ring the bell for notifications so you don't miss out on anything when they get posted. And share with a friend. Thanks for watching.